Later in class, we'll come back to this, but you should be able to kind of correlate each graph that's occurring over time and what it's doing to the other graphs. All right? So as you're sitting there befuddled, right, we'll come back to that skill. But right now, we have to take a detour to EKG by learning this thing. So, okay, so in your heart, you have these things. Fancy words, intrinsic conduction system. What does it mean to be intrinsic? You learned that last week. What's intrinsic mean? Within, right? Conduction means to carry a message. So these things carry messages within the heart. Here they are. You only have to know about 2 of them for lecture. These yellow bumps here and here, those are part of the wiring, the nerves of your heart. So your heart has, quote, nervous system parts in them. That tells the heart what to do. Why would your heart need to know what to do when? Why is that important?
Like you need to increase your heart rate.
Right, you increase your heart rate, otherwise I die. Remember, the heart has to work in union, right? Both sides have to beat as a T. So I need someone to conduct or control who beats when. And so these things here are telling your heart a one-a and a two-a, a one-a and a two-a, right? When to go, when to beat. Just like an orchestra needs a conductor, this is the same concept. So in case you're in mechanics, your car has a computer for each spark plug. Tells it when to fire. Your heart has the same thing. It has a computer, tells it when to fire. That's what these are. So on this picture here, this is not anatomically correct. You don't have balls in your heart. Oh, maybe you do. This is showing the information pathway between those electrical wires and my heart. So we're going to take a look at this and see if we can figure out what part of the heart is talking to what part. So we're going to put that over here. So as you're looking at that, let's start writing down the parts of the intrinsic conduction system. Believe it or not, there are only 2 parts in there we have to know for lecture. First one we have to worry about is this yellow ball right there. What is that yellow ball right there called? Look on the screen. The SA node. So the first part of your system that we're talking about is the SA node. If you don't like that word, maybe you don't. The other word for that was your pacemaker. What does a pacemaker do? Sets the pace, right? 1 and 2 and 3 and 4. So its job is to tell the heart when I want you to contract. Set the pace. Okay, so when the pacemaker sends an impulse, when the gray balls come out of the pacemaker, what does the heart do? Okay, it contracts. What part of the heart contracts? The atria contract. Very good. So when this depolarizes, that makes the atria do systole. Look at those words, huh? Okay, tell me what depolarization meant last term. What does depolarize mean in 231? Sodium, potassium, that's the nerves fire, right? So these are nerves. They're going to fire or depolarize. That's going to make the chamber squeeze. Everyone see the logic there? So you have nerve words and muscle words. So I'm going to depolarize my SA node, causing my atria to do systole. So this computer runs these 2 chambers, the top of my heart. And they're squeezing, and that fires, bam, they squeeze. Why are they squeezing? To force blood in the heart. So what step was that here? When the pacemaker fires, what step is that? Number 2. So your pacemaker is responsible for step number 2. I want the atria to go. I want to load my heart. Kick. That make sense? All right, let's go to the next node. But before we do that, we need to have a delay. So there's a delay, and then the next node fires. So here's my SA, here's a delay, and then this one. So which one's that one? That's the AV node. So number 2 is the AV node. When it depolarizes, can someone tell me what part of my heart is doing what? What is it?
Ventricle contraction.
Very good. Give me doctor word for ventricle contraction. Ventricular systole. Very good. So if you look, the gray balls come out of this one, and then these things squeeze. So atria, ventricle. Depolarize, depolarize. Everyone seen that? So why am I squeezing my ventricles? Okay, boys, bye-bye. What step is ventricular systole? The 8 steps you're supposed to memorize by next week. 3 and 4, right? I'm squeezing my blood to force it out of my heart. So I'm going to squeeze, close, open. Make sense? Okay. So now our next question. When they're not sending messages, what is the heart doing?
Relaxing.
Relaxing. So we have no response. We're going to relax our heart. What's the doctor word for relaxing the heart? Diastole. So when neither node is firing, the heart is going to relax, or diastole. What steps were that? I think it's over here. Isn't that here? 7 and 8? Very good. So we can correlate the 8 steps you're going to memorize with these parts of the electrical system of the heart. So these are telling you which step the heart's trying to do. Make sense? Now we're going to make it a little more difficult. Okay? Because now we're going to do it graphically. You know I love graphs. So that, tracing, is what you're going to do with the ER, or EMTs do it. This corresponds to what those things on the board are doing. So we have the P wave, a QRS complex, and a T wave. If you read down here, they're saying what those bumps or blips or deflections are doing. So the P wave is atrial depolarization. Can someone tell me on what I just put on the board, which node would be responsible for atrial depolarization? The SA node, which is the good pacemaker, gives you a P. So the pacemaker is sending the P wave when it fires. So that P wave means I've depolarized my pacemaker. My atria should contract if my heart is normal and healthy. Make sense? So I'm measuring that node. Okay, Smarties. QRS complex. Read that and tell me what node is doing the QRS complex. That's the AV node, because it does ventricular systole due to depolarization. So the QRS complex is my AV node signals my ventricles to contract. That makes sense? Okay, now notice there's a T wave. T wave corresponds to ventricular repolarization. Repolarization is another way to say what? Relax, which is another way to say bingo. So you have P, QRS, T. Those waves correspond to my pacemaker, my AV node, and then they're relaxing or not responding. So you get 3 waves to correspond to these basic 3 parts of the heart. So those electrical signals are telling my heart which step they should be doing when. Okay? Now, let's put this together. So with your 3 eyes on the right-hand side of the screen and your 5 eyes on the next side of the screen, you're going to watch both of them together. So here we have the nodes, here we have the chambers, here we have the impulse, there we have the graph. So during the P wave, that's my pacemaker, SA node, telling my atria to contract to preload my heart in step 2. There's a delay, which is this little one here. Then a QRS complex is the AV node sending messages to my ventricles to contract to push the blood out. T wave is when both of them turn off and my ventricles relax. P, QRS, T. P, QRS, T. Atria, ventricle, relax. 2, 3, 4, 7, 8. Makes sense? So visually in your mind, you'll be able to walk through those P, QRS, and T's and those signals, right? So let me help you with that slightly. So if we put that in a static form, here's my EKG tracing. So when my pacemaker or SA goes, I'm going to cause the P wave deflection, like that. And that should be telling my atria to contract in a normal, healthy heart, like that. Right? So lighting up, they're glowing, they've got an impulse. Right? So then my AV node will start talking to my ventricles, causing the QRS complex. Right? QRS complex, QRS complex. Then I'm going to start relaxing my heart. As I do that, I get the T wave deflection, which means I'm relaxing or expanding my ventricles, and they go back to before. Right? So the P, QRS, and T are the electrical signals telling my heart when to contract. It's just timing the heart for me. Make sense? All right, so if that made sense, let's go back to this one. Now what we're going to do now is go back to those graphs we just did. So top is the ECG or EKG. I see PQRST, PQRST. If I look over here, I should see my atria and ventricles corresponding to those electrical signals. So let's do that together. So the P wave tells my atria to contract. QRS should tell my ventricles to contract. T wave should tell my ventricles to relax. Right? And that's what I'm getting. So again, this is what you're supposed to understand when all of them are together. Right? So what we're going to do is make it a little easier for you. I'm going to put up a single picture of all those graphs, which will look just about like, let me get the right. Here we go. Boom. Take a picture of that with your phone, because thou shalt know how to interpret those thou shalt. And we'll go through it again. So you want that to study from for the rest of your life. It's also in your book, by the way. You lights on or off? Does anyone care? Off. Off is better. Got it? I'll wait a while for everyone to get it. That's why. Okay, let me know when you have them all. So. All right, so let's see if I can walk through the thing I'm demanding of you, right? So again, I'm not going to ask you to draw these. That's not the point. What you have to be able to do is walk yourself through verbally or mentally what each graph is saying and why it's saying it and how it's influencing the other one. So if it were me, I'll start at the top. I'm going to do my P wave first. P wave should tell my atria to contract, so my atrial pressure is rising. Why is it rising? To preload my ventricle to increase its stretch, right? Then my ventricle is going to contract, or systole. It's going to get smaller. That has to close the valve, lub. That forces the pressure to go up in the ventricle, eventually overcoming the pulmonary aortic valves, which then allow it into the artery, which is here. And then that declines, I dub to keep it there. Therefore, these now begin to relax or diastole because my T wave says to. So something like that, where you can walk from one graph to the other and mentally walk through each thing, the valves, the chambers, the contractions, the EP, QRS, and T, and the blood. Right? That's your job for this week. One of your jobs for this week, yes?
The purple line is the aorta pressure,
Yes.
right? Okay.
Yeah, and this one is purple. Right. So you have an electrical signal to correspond to heartbeat, to correspond to valve, to correspond to blood. Make sense? Yes.
Can you say again the pressure in the left ventricle and exactly the timing of when the blood it's like most full and when the valves open?
So the preloading would be where the atria contracts, so right here. That's the fullest your ventricle would be. So that's fully preloaded or kicked. So then when the QRS fires, here, bam, the ventricle begins to squeeze, zoop, which forces the valve to close and forces the blood to go up in pressure until it opens the aortic valve, which then has this graph here. Does that make sense? And then when the ventricle begins to relax, the blood's going to start coming back in, but hits the valve, bam, which forms that notch. The ventricle is then going to keep expanding, which lowers the pressure. And then the atria then will kick in again and begin to load in step 8, basically. So you're going to have your lub and your dub, lub, dub, corresponding to closing and opening these valves in the different stages. Make sense? Not at all. It'll take a while. But yeah, be able to interpret your way through, and this chamber's doing that chamber's doing this, that valve is doing that. That's what you got to do. But we're not done yet. We're almost done. Because we have more to learn. And that is how these nodes actually make a signal. So we need